Hello everyone. In this lesson, we will work with finding the derivatives of inverse function, sine, cos, and tangent, and the notation for them will be sine to the exponent minus 1, cos to the minus 1, and tangent to the exponent of minus 1. So before we get started, I would like to remind everyone of the essential formulae that we have been using earlier, derivative of transcendental functions. In this lesson, we will work with formula number 7, 8, and 9. Alright, so let's get started with question number 1. So to work with this question, I would like to begin by remind everyone that derivative of sine to the exponent minus 1 of u as a function of x will be equal to 1 divided by square root of 1 minus u squared times du over dx. So you see, in working with derivative of transcendental function, we always multiply by derivative of u as a function of x. And in this case, u will be defined as 1 minus 2x squared. So we will write u equal to 1 minus 2x squared. So immediately after this, I will take derivative of u as a function of x. Okay, so derivative of 1 will be 0. Derivative of negative 2x squared will give me negative 4x. Alright, and it's a good idea to find u squared as well, because you have to take 1, subtract the u squared. So I have u squared will be equal to 1 minus 2x squared, all of it to the exponent 2. So to work with this, I would like to remind everyone of another formulas. So if you have a minus b, all of it squared, okay, so you have the formulas as a squared minus 2ab plus b squared. So it is another special product formulas for the binomial if you raise this binomial to the exponent 2. However, if you don't want to remember these formulas, you can always expand this. Okay, expand this by writing 1 minus 2x squared multiply itself one more time, and then you expand them by multiply them out. However, follow these formulas. I will have u squared equal to 1 subtract 4x squared plus 4x to the exponent 4. Okay, so on the side, I can tell everyone that you can work with the expansion as well. So 1 minus 2x squared, all of it. So you multiplied it out twice. Okay, so then here's the procedures. When you void this out, you should have 1 minus 2x squared minus 2x squared plus 4x to the exponent 4. And then you see you combine these two terms, you should have 1 minus 4x squared plus 4x to the exponent 4. So it does the same thing as I use my formulas up here. Alright, okay. So let's fit all of what we find into this equation. So I will have it equal to, so I will write dy over dx now that I'm differentiating. So I will have 1 divided by square root of 1 and minus this entire expression, right? So I will have 1 minus 1 minus 4x squared plus 4x to the exponent 4. So when I write it in here, I will take into consideration the minus sign in front of the bracket. So I will have that as minus 1 plus 4x squared subtract 4x to the exponent 4. And this whole thing will multiply by negative 4x. Alright, so now simplify what I have in the bracket. I should have it as that cancel out. Okay, so what I will do is I will take a look at my 4x, and then I am going to factor out the common factors. Okay, the reason I factor out the common factor so that I can cancel out with what I have as the numerator, which is negative 4x. But don't forget that I am having the square root So I will factor out the perfect square so that I can simplify and take it out of the square root. So in this case, I will write dy over dx as 1 divided by, so I will factor out the 4x squared. Alright, so 4x squared, I should have 1 minus x squared left inside the bracket. This is multiplied by negative 4x. So this will be 1 divided by 4x squared, bring it outside the bracket. I should have it as 2x. So the 1 minus x squared left inside the bracket, so multiply by negative 4x. So I can see that x cancel out, that and that will give me a minus 2. So my final answer should be minus 2 divided by square root of 1 minus x squared as the final answer. Alright, so for this question, what we have to remember is differentiating the argument, okay, and substitute it into these formulas, and we have square root of 1 minus u squared, so you may as well expand your u, and then don't forget it's a minus 1 minus the entire bracket, and in the end it's just apply the algebra to simplify your final answer. Alright, so let's move on to the next question. The next question is cos to the exponent minus 1 of x divided by 4. So again, I would like to write the formula that I need to use. So derivative of cos to the minus 1 of u as a function of x is equal to very much similar to sine, except you have a minus 1. Okay, so 1 minus u squared times du over dx. So this is the formula that we need to use. Okay, so let's get started with u equal to x over 4. Okay, so and then we differentiate this. To make it easier for everyone, I would like you to notice this 1 over 4 times x. Okay, so therefore du over dx, which is be equal to 1 over 4. Okay, so what about u squared? So u squared will be equal to x over 4, all of it squared. So I will have it as x squared over 16. Alright, so make sure that you take the fraction to certain exponent. It means that you have to raise each of this to the exponent. Okay, so let's substitute what we found into the formulas. And again, all the tedious stuff is just the algebra part of it. Okay, so I write dy over dx equal to, now I will write minus 1, the whole thing divided by square root of 1 minus x squared over 16. And this whole thing here is multiplied by 1 over 4. So the next step I'm going to do is I want to simplify what underneath the square root. Okay, so inside the square root I have 1, subtract x squared over 16. So for me to simplify my radical, I will perform the operation. Alright, so I perform the operation by taking the common denominators. Okay, so by taking the common denominator, I should have 16 minus x squared over 16. Alright, so this is times 1 over 4. I still have to leave that. Okay, so what I'm going to do next is I notice 16 is a perfect square. Alright, okay, so what I will do is I will factor out the 1 over 16. Okay, 1 over 16. So inside the bracket, I should left with just 16 minus x squared. Okay, as the denominator in this case. So right here I have times 1 over 4. Okay, don't forget that. Then you see this 1 over 16. I can pull it out of the square root. So I can put it as 1 over 4. and the square root of 16 minus x squared, and this still multiplied by 1 over 4. So the purpose of that is I would like to write it in a way that you see you multiply by 1 over 4, and here is 1 over 4 as the denominator. You can go ahead and cancel this out. That cancel with that. So then my final answer, dy over dx, will be equal to minus 1, the whole thing divided by square root of 16 minus x squared as the final answer. Alright, okay. So let's move on to the next question. So in this question, I am finding the tangent inverse of the argument, and my argument is secant of x plus tangent of x. So we have to use a few formulas to work with in this case. Alright, so let's get back to our formula sheet. So in this case, you see tangent to the exponent minus 1 of an argument. Taking derivative of this, it will become 1 over 1 plus u squared times du over dx. But we are having the secant x plus tangent of x, so you are using this formula as well. So you will be using number 5. Secant of u will be secant of u times tangent of u times du over dx. You also have to find derivative of tangent, which is formula number 3. So derivative of tangent will be secant square u du over dx. So for this one question, for this question alone, okay, we are going to use 3 formulas. Okay, so we are going to use 3 formulas. So there will be formula number 9, formula number 3, and formula number 5. Alright. So I will eventually write all of that down for everyone to remind everyone. So derivative of tangent to the minus 1 of u will be equal to 1 over 1 plus u squared, then times du over dx. Okay, so what we do is we are going to let u equal to, okay, so let u equal to secant of x plus tangent of x. So to take derivative of this, so derivative of secant, that means you are going to use this formula. Derivative of secant is secant, again repeating, multiplied by tangent of that, and multiplied by the derivative of your argument. But in this case, your argument is x, so therefore that derivative is just equal to 1. So I will write this as secant of x times tangent of x. Okay, so that is the derivative of secant of x. So now derivative of tangent of x is derivative of tangent of x, in this case, according to our formulas, is just equal to secant square of the argument and multiply by derivative of that argument. So in this case, it's just equal to 1. So I will write it as secant square of x. Okay, so multiply by 1, I don't have to write that at all. Alright, so let's figure out secant square plus tangent square, because secant of x plus, secant of x plus tangent of x, all of it in the bracket square. So because you have to figure out the u square in this case. Okay, so we can do it right away when we differentiate as dy over dx. We don't have to do it on the side because of the 1 plus. So here's a plus sign, so I can just do it right here. Okay, while writing this, substitute into these formulas for everyone. So 1 over 1 plus u square. Okay, u square means secant of x plus tangent of x, all of it square. Okay, so this is your u square. So remind everyone of these formulas. Okay, the special products. So I will follow these formulas and put everything in here. So I will have secant square of x plus twice secant x tangent of x and plus the tangent square of x. Alright, so now I have to multiply by derivative, so I mean secant of x tangent of x plus secant square of x. So this is my du over dx here. Okay, so the next step is to simplify. So I would like everyone to take a look at what I have in this case. Okay, so we have 1 plus secant square of x plus twice secant square of x tangent of x plus tangent square of x. So in order for us to simplify this, we have to use a trig identities. So let me get back to the formula sheet that I show everyone. Underneath here, I identify some trig identity for you to use. Alright, okay. So I would like you to use 1 plus tangent square of x will be equal to secant square of x. So in this case, we are going to choose two terms in the denominator so that we can simplify. So I am going to choose 1 plus tangent square of x. It will become secant square of x. Okay, so 1 over trig identity, so that will be secant square of x. Okay, so I will make a note here. So let me make a note down the bottom. Okay, note. One plus tangent square of x will be equal to secant square of x. So as trig identity. So when I do that, I will left with plus secant square of x plus twice the secant square of x tangent of x, and the whole thing multiplied by secant of x tangent of x plus secant square of x. Okay, the purpose of this is for me to simplify later. So what I'm going to do now is I am going to add this two. Okay, so this two adding will give me 2 secant square of x plus 2 secant x tangent of x. Okay, so this should still be divided by so equal to this to divide into 1 times secant of x tangent of x plus secant square of x. Okay, so now I would like everyone to see that you have this as the you can factor that out as common factor. Okay, so let's try that to see what happened. Okay, so I am going to write it as, okay, so you see that I can take out the 2 as a common factor. So I can do this 1 over a half, right? Okay, so then I can have it as if I write a half, then I should write it as this. But however, I'm not going to write a half. I hope you understand what I mean by that. Okay, so if I write a half, I should not divide into 1 anymore, so I can write it as this. Okay, that means I take out the 2 as a common factor. So that's what I meant by that. But I am going to just write the 1 right here for everyone to see. But I factor out the 2. So in here I have secant square of x plus secant of x tangent of x. Okay, I multiply by the exact same thing here as the numerators. Okay, so that means this whole thing is cancelled out with that, and my final answer it's just equal to a half. Alright, okay. So my final answer is equal to a half. Okay, so I hope it's clear for everyone. In this case, I have secant square of x plus secant of x times tangent of x. But this one is termed with just at the reverse position here. But it doesn't matter to represent the same thing. So I can take this whole expression, cancel with this whole expression as the denominator, but I must have a multiplication here. Alright, so I factor out the 2. I have it left in the bracket, so that is exact equal to what I have as a numerator. I cancel them, my answer will be equal to a half. Alright, so in working with the inverse function of sine, cos, and tangent, we pay attention to these formulas, and all we have to do is just differentiate the u, and then we have to use a few knowledge of algebra. We have to review some concept of algebra in this case so that we can apply and simplify what we need to simplify. Alright, okay, so I do have another reminder for everyone. If your argument is another trig function, then in order for you to simplify, you may have to use some trig identities. Okay, so trig identities. If you want to use some trig identity, go to the formula sheet that I prepare for everyone. It's the essential formulae for derivative of transcendental functions. I posted one of this document as well. And pay attention to these trig identities, and you may want to choose some of these here in order to simplify your answer. Alright, and I do have a few questions I would like everyone to try. Okay, very much similar to the example that I have given here. So make sure that you try this question and then check solution online. Alright, thank you.